Hello, everyone. Welcome to IE 330 Engineering Analytics. In this lecture, we are going to have a brief introduction to engineering analytics. Let's first have a look at the outline of this lecture, including admin and data deluge, analytic landscape, and what can data analytics do. So for the syllabus, we have a separate video about to talk about the syllabus. Please check out that video. And time and the location of this class. This class is a COVID-19 web class. So it's going to be fully online and asynchronous. We are not going to have an in-person meeting location. So email communication via Canvas. Please send your emails through the Canvas messaging system. Please do not mix the class email with my general emails, because this will sometimes cause me to overlook some of your emails because there are too many general emails in my official Penn State email address. So in order for me to timely respond to your request and emails, please send emails through the through the messaging system and the email system in Canvas. And the grading policy is available in the other video of the syllabus. Please check out the details. The textbook is available in this link. It's a PDF document fully available online. The authors and Springer has made this textbook fully available online. Please check out this link. So why do we want to study data analytics? Because there are a lot of data right now in the modern industry, especially with the recent advancement of Internet of Things and fifth generation telecommunication network. So we use a lot of advanced sensors and collect a lot of data. So as we can see from this slide, and it can be in the hospital, healthcare industry, manufacturing industry, semiconductor industry, all the business like retailing industry, or online shopping. In the healthcare, as we can see here, hospital has hospital patient registries. In every clinical trial, they are going to connect a lot of data, a lot of registry data. In the Best Buy, Walmart, either online or in store, they have a lot of electronic point of sale data from all the customers. So if we look at three categories: business, manufacturing, and healthcare, as shown here. The business has bank transactions, catalog orders, stock trades, airline reservations, tax returns, credit card charges. And manufacturing has data. Now we're talking about the Industry 4.0, the fourth generation, fourth revolution of the industry. So digital factory and smart manufacturing, we are using a lot of sensor networks. PLCs. PLC stands for Programmable Logic Controller. They are widely used in the manufacturing plant. And sensors, we could have temperature sensors, flow sensors, current sensors, acoustic sensors, vibration sensors. In healthcare, definitely we wanna get a lot of information or information visibility of a particular human subject, because we want to know what's going on and what is the health status of this. Or if there's problem, then what kind of problem, and what is the progression of a particular disease, and how can we reverse and take care of the patient. So that's why the medical technology give us a lot of data. For example, MRI, CT, EKG is electrocardiogram, blood test, variables. And so with all this technology, we have a lot of data in each industry. Now we need to better prepare our students for this data deluge, Okay. Now let's have a look at a few examples. Now this is a video link. Let me see whether I can play here. No. Let me click this link. Okay, now let's have a look at the examples.
Being first across the finish line requires more than flawless aerodynamics and legendary driving. Today, Formula One racing is also fueled by data. 150 sensors monitor car and driver performance around every corner. These sensors track vital stats like engine performance, tire health, brake wear, and driver biometrics. In one lap, they will collect and transmit 2 gigabytes of data. In a single race, a staggering 3 terabytes. Analysis that previously took almost a week to process can be completed in the span of a pit stop. Back at McLaren Mission Control, engineers and experts analyze race data and work to maximize performance for the car and the driver.
So in the first example is Formula One. For every car in every lap, every millisecond, we connect a lot of data to know the operational status of the car. And as you can see from this example, every second we generate a gigabyte of data. And then how do people utilize those data, extract useful information from those data, and then leverage those information to maximize the performance of the car? So this is the first example in the racing.
Make critical decisions at every turn, through every lap, every heartbeat. Strategies evolve as the race progresses, and powerful predictions help light the path to the podium. Now McLaren can compare 10 years of historical data against the real-time race feed in every calculation. This enables the team to make more confident predictions and help guide their drivers on the track. Confident predictions mean faster, more informed decisions, and informed decisions win races.
So second example is about digital factory.
A vision of tomorrow's manufacturing. Products finding their way independently through the production process. In intelligent factories, machines and products communicate with each other, cooperatively driving production. Raw materials and machines are interconnected within an Internet of Things. The objective, highly flexible, individualized and resource-friendly mass production. That is the vision for the fourth industrial revolution. A bottling plant for liquids set up together with Siemens is used to demonstrate the most important components of the intelligent factory of the future. Each bottle contains an RFID chip storing a precise description of how it has to be processed, which liquid, which lid, and which label. At each station, the bottle communicates directly with the machine, telling it how it has to be processed. At the end, a computer checks whether the bottle has actually been produced as desired. Factories with networked machines and products are already in existence today. In the future, however, these hitherto self-contained systems will be connected together in a comprehensive network. All devices, machines, and materials will be duly equipped with sensors and communications technology and connect to each other. These systems are known as cyber-physical systems. The highlight is that they communicate with each other and also control each other cooperatively.
Ja, die Vision sieht so aus, dass wir ein Internet quasi hinunterziehen bis auf die unterste Ebene. Das heißt, jeder Sensor, jeder Aktor wäre damit quasi ein Teilnehmer eines Internet der Dinge. Jedes Gerät hat damit eine eigene IP-Adresse, ist damit adressierbar in diesem Netzwerk.
For the customers, this means tailor-made products at relatively affordable prices. For industry,
the third example is about the health
monitoring
wearables.
devices, including wearable technologies, are being unveiled by hundreds of companies, allowing individuals to collect data on their physical activities and calories burned, also their weight, heart rate, blood pressure, hydration, blood sugar, sleep, and other bodily activity, some of the earliest adopters have already collected years of data on themselves. So could wider self-monitoring improve everyone's health? Potentially, say experts. Let's start on the micro level. Personal health. New app platforms are now emerging that allow users to aggregate their individual metrics. Coming soon to a smartphone near you, Apple's HealthKit framework, Google's Google Fit, and Samsung's Sammy. All three are designed to collect metrics from popular tracking devices and apps. Here's where things get more exciting. Up in the cloud, all these disparate data points can be cross-analyzed, changes tracked, correlations discovered, offering the possibility of optimizing our health.
So these are the 3 examples of the data deluge. As we can see, we have racing industry, racing car, and the digital factory, and health wearables. So 3 consequences of the big data. Now, every problem will generate data eventually. So why not we proactively define data connection protocols? So what does this mean? This actually is a design of experiments in industrial engineering. I believe many of you will learn design of experiments. That is, you design the experiments to connect the data. These are called active experiments. Of course, they are passive. For example, sensors, you just put it there, you didn't design experiments, and they passively, you have a lot of observations. So you wanted to proactively design the experiments and define the data connection protocols that will bring more useful data and more information, and then more useful analytics. Every company will need the analytics eventually. Those companies who don't do analytics will not have competitive advantages in the market. So proactive analytic companies will have competitive advantages. We will compete more effectively. Everyone will need analytics eventually. Proactively analytic people will be more marketable and work more effectively in their jobs. As we can see from this picture, we have a lot of data, but the useful data may be only a small section, okay? So you have tons of the data, and you're trying to find out anything useful. But how do you define something is useful? That is dependent on your business objectives or business opportunities. That means, what is your research objective? What is your analytical objective? And then you want to find the relevant data to help you achieve that objective or explore a particular business opportunity. And so we have a lot of data, so we need data management, and then we need information extraction, because the useful information is only a small chunk out of the big data deluge. Okay? So then we can discover the knowledge and help us make better decisions, better informed decisions. Now, business, manufacturing, or healthcare. So we hope that there are definitely hope for the data deluge, and the data scientists, analytic tools, engineering analysts. We need to work together. It's not just about data scientists can do everything, okay? We also need domain expert, right? Which can tell you how the process works and what kind of problems they are facing and how can we use data to solve those problems. Not only you become a data scientist, and then you master those analytic tools, and then you talk with engineering domain experts, then we can derive actionable knowledge, help us to identify those opportunities to improve your business. So the nanoscape, there have been changes in the analytical nanoscape. Previously, analytical modelers, for example, the data scientists, and they build the model, and then they send the report to the back office, and then back office analyze the report sharing only among a few individuals. But now the analytics is pushed out to the front office, directly impacting company performance. Now, if you have analytical modelers, now there are more models will be developed. It's not just the sparse models as before. There is a proliferation of analytic models. Those models bring clear and tangible benefits, and the management can track and to different departments in the company, for example, to the operations including customer service, retail, logistics, and promotions, and human resource, right? And the target, including customers, suppliers, employees, and stakeholders. All parties will be involved in the process. And so that's why people, you and all the students, you need to become an analytic expert or master the analytic tools so that you can be more competitive in the future. Now, how do we achieve a success with data analytics, or what kind of analytics can we do? You see, in the x-axis, we have data, information to intelligence, okay? And in the y-axis, we have competitive advantages. There are 3 different groups of analytics: the advanced analytics, basic analytics, and simple reporting. So for the simple reporting category, you see, so first, the basic reporting. Based on the data, at least we want to know what happened, and then have some visualization to show what happened to the company: revenue increase, and earning per share, and how do they increase or decrease. The ad hoc reporting: how many, how often, and where. Okay, for example, which department didn't perform well in the company for this year, and how often they have been doing that, right? Lose money, right? And then dynamic reporting: where exactly are the problems? So those are the simple reporting, and you just gather the data, visualize the results, and identify the problems, and generate a report. And then we can go to the basic analytics, which include basic statistic analysis and a report with early warnings. What actions are needed? Why this is happening, right? What are the root causes for this? And after basic analytics, we can go to advanced analytics. For example, the decision optimization, predictive modeling, and forecasting. What if these trends continue? What will happen next? And what is the best decision to mitigate those effects, right? Or to improve the performance of the company. So decision support is trying to guide a better decision-making process for the future. So those are different stages of the data analytics and how they can help the company achieve successes. Now, what are the data analytics, and what kind of questions can data analytics answer? And we talk in the very high level, but now let's look at a few specific examples. So the 5 questions here: is this A or B? Is this weird? For example, you want to classify this is A or B, right? True or false, or diseased or healthy. Second question is this weird? And how much, how many? And then how is the data organized? And what should we do next? So now let's look at a specific example for each question. The first one is a classification problem. It could be 2-class classification. Is this A or B, healthy or diseased? Or this could be a multi-class classification. For example, the character recognition. And if you write some letters and some sentences, how can we recognize those sentences with a computer? So we can recognize A, B, C, D, E, F, G to X, Y, Z. So we have total many characters to recognize. So those are multi-class classification. If you write a particular character, what is it? Can computer tell? Maybe you have a very good writing, computer can tell right away, but some others may have very bad writings, you know? And the second question is this weird? Weird means anomaly, whether there's any anomaly in the process. Okay, so this is anomaly detection algorithms, whether the intrusions to the system, to the network, or whether the machine tool work properly. And So quality controls whether there are bad parts generated from the process and tire pressure. So those are the anomaly detection. And also you can use regression or regression problems. Regression problems can tell you how much, how many. For example, what will be the temperature next Tuesday, right? Based on the history, can you predict or do the predictive modeling of what will happen next day? Or the sales next month. And you can also predict the wage, for example, based on the person's profile. The profile might include age, year, and education level, and also demographics. So you want to predict what kind of wage he approximately get in this area, right? In this local area, for example, in Center County, Pennsylvania, or in Philadelphia. Now, the next one is how is this organized? This is a clustering problem. For example, you have data points and you see the clustered into groups. So these are the data structures. So Netflix do a lot of this kind of clustering because they want to cluster the viewers into different groups. For example, viewers like the same type of movie so that they can do some recommendation systems in the Netflix. This is done not just in Netflix, in Disney Plus, in Hulu, or in many streaming video service providers. And also it could be done in the healthcare. For example, the gene expression, group of cell lines or different cancer types. The next one is what should I do next? So because you can predict this, you can predict that, but what should you do next? This is in the category of reinforcement learning. Okay, and so based on the temperature in the house and the smart home device, Nest can adjust right up and down. And the autonomous car driving, you can turn left, right, or stop. So which one should you do, right? And you need to have radar, camera, and all kinds of data, so that it can help you to accelerate left, right, or brake, different kind of actions. And you can also see the DeepMind and AlphaGo. And AlphaGo is actually a computer DeepMind, deep learning algorithms playing the chess. So you see, when you play the chess, there are board positions and you have stones. Where do you want to put your stone? And those are all the decisions you want to make. They also welcome robotics. If you bought an iRobot at home and try to clean the floor, and should you, based on the battery level, should you continue to search and clean the floor, or should you go back to charge? So those are all the decisions an AI agent has to make. Okay, so this is the end of this lecture, and the reading assignment is chapter 1 of the textbook. Please go ahead and read the textbook. Okay, this is the end of this lecture.